So we've looked at three methods for solving systems. We've got graphing, we've got substitution, we've got elimination. We have not looked at a situation that pops up every once in a while, two different situations actually. So let's take a look at those. We've got simple system here, 3x minus 12y is 6, 2x minus 8y is equal to 4. And we can solve that by whatever method you want to solve it by. I'm going to solve it by elimination because that's my favorite. And I didn't really talk about this last time, but what we're looking for when we try to eliminate one of these is the least common multiple of these numbers. So the least common multiple of 3 and 2 is going to be 6. So to get that in front of each of them, I would have to multiply the top one by 2 and the bottom one by negative 3. Okay, because I want to have different signs in front of them. So 2 times the top one will give me 6x minus 24y equals 12. And multiplying the bottom one by negative 3 will give me negative 6x, positive 24y, and then negative 3 times 4 is negative 12. And what's going to happen if I add those two together is everything's going to cancel. And I'm going to be left with nothing on the left and nothing on the right. Now what that means is that these equations are essentially the same. And you can see if we were to have divided the top one by 3 and divided the bottom one by 2, we would have gotten x minus 4y equals 2 for both of them, identical equations. And that means since they're the same, anything that works in the first one would also work in the second one. So we have a situation where we're really just dealing with one equation. And as we discussed before, there are infinite solutions to an equation that's got two variables. So when both sides cancel out and you're left with 0 equals 0, that means there are infinitely many solutions, which means that anything that works in the first equation is also going to work in the second equation. Now they may ask you in my math lab for a little formula here. I don't want you to bother with that. They may have another box that says y equals, and you're supposed to put something in there. I really don't care about that, and I'm not going to ask you for that on any test that we're doing. So 0 equals 0, infinitely many solutions. Similar situation here. If we want to cancel, I'll cancel the y's this time. I need a 2y down here. That's easy to get just by multiplying the bottom one by 2. So the top one, still 4x minus 2y equals 3. The bottom one's going to be, I got to change the sign, right? So multiply by negative 2. I'll get negative 4x, positive 2y, and then a negative 8 over here. When I add these together, the x's will cancel, the y's will cancel. That'll leave me with 0 on the left. Over here, 3 minus 8 gives me negative 5. So what this means is, in order for both of these equations to be happy, then 0 has to be equal to negative 5. 0 is not equal to negative 5. So these two equations are never both going to be happy, and we have no solutions. No solutions. Okay, that means that those two equations, there's no pair of numbers that can make both of those equations true, because in order for that to happen, 0 would have to be negative 5. So if everything cancels, you get 0 equals 0, infinitely many solutions. If the left side cancels, but you're left with a number on the right, you're left with an equation that is untrue, nothing can make that true, there are no solutions. And those are the only special cases you're likely to run into. I don't know if they're going to be ugly numbers in my math lab. I tried to avoid them, but as you know, I'm not very good at avoiding ugly things in my math lab. Talk to you next time.